Hello everyone. Today we'll discuss the question and answers. So welcome to the session 4 for motion and time. Let's jump right into it. Uh, let's start with question 1. Classify the following as motion along a straight line, circular or oscillatory motion. इसमें हमें बताना है कि इनमें से दिए हुए which of the motion is a straight line, circular and which motion is oscillatory motion. Oscillatory motion is also periodic motion which you studied in class 6. So question 1, motion of your hand while running. तो दौड़ते हुए आपका मोशन कैसे होता है? दिस इज हाउ यू एक्चुअली रन. सो दीज आर योर हैंड्स and when you're running they go front and then they come back, they go front and then they come back. So there's a repetitive motion, repeat होते रहता है, and then that's why this is a periodic motion. So the answer for one is an oscillatory motion. Second, the motion of a horse pulling a cart on a straight road. तो अगर एक स्ट्रेट रोड है उस पे एक अगर कार्ट जा रही है तो वो कैसे जाएगी? इट ऑफ कोर्स गो स्ट्रेट. सो दिस इज अ स्ट्रेट लाइन मोशन. थर्ड का आंसर क्या होगा? मोशन ऑफ अ चाइल्ड ऑन अ मेरी गो राउंड. तो मेरी गो राउंड क्या होता है? मेरी गो राउंड इज एक्चुअली वो एक झूला होता है. इट्स अ राइड इन एन अम्यूजमेंट पार्क. तो वो ऐसे राउंड राउंड जाता है, ठीक है, एंड किड्स कैन सिट ऑन इट. तो व्हाट इज दिस? दिस इज अ सर्कुलर मोशन. ओके. द फोर्थ, मोशन ऑफ अ चाइल्ड ऑन अ सी सॉ. तो एक सी सॉ कैसे होता है? यहाँ पे एक सीट होती है और यहाँ पे एक सीट होती है, एंड दिस गोज अप एंड देन दिस गोज डाउन. फिर ये ऊपर जाता है और ये नीचे आता है, फिर ये ऊपर जाता है और ये नीचे आता है. सो अगेन दिस इज अ रेपिटेटिव मोशन which happens over a period of time. So what does this motion become? This motion becomes oscillatory motion. फिर नेक्स्ट है मोशन ऑफ द हैमर ऑफ एन इलेक्ट्रिक बेल. तो एक इलेक्ट्रिक बेल कैसे बजती है आपके घरों में? अगर बेल है तो उसमें क्या रहता है? देयर इज अ gong and then there is a small hammer here which operates with electricity. तो जब आप अपने घर की बेल बजाते हो, you press this bell, तो क्या होता है कि this hammer it goes front and back, front and back, front and back, front and back, and then it hits this bell here. It hits this gong. एक प्लेट टाइप होती है जिसको ये बार बार हिट करता है जिससे आवाज आती है, ठीक है. तो वो जो आवाज आती है वो इसके रिपीटेटिव मोशन से आती है, ऑक्सीलेट करने से, वाइब्रेट होता है ये, ठीक है. सो द फिफ्थ क्वेश्चन आंसर इज अगेन ऑक्सीलेटरी मोशन. एंड देन द लास्ट वन इज वेरी इजी, मोशन ऑफ अ ट्रेन ऑन अ स्ट्रेट ब्रिज. तो अगर एक ब्रिज पे एक ट्रेन जा रही है, ठीक है, और वो ब्रिज स्ट्रेट है तो वो ट्रेन कैसे जाएगी? इट्स नेचुरल कि वो स्ट्रेट लाइन में जाएगी. ओके. सो योर आंसर्स आर ऑक्सीलेटरी, स्ट्रेट लाइन, सर्कुलर, ऑक्सीलेटरी, ऑक्सीलेटरी, and then straight line, right? So let's move to the second question. Which of the following is not correct? तो हमें कुछ ऑप्शंस यहाँ पे, कुछ क्वेश्चंस यहाँ पे दिए हुए हैं और हमें बताना है कि इनमें से करेक्ट कौन सा है और इनकरेक्ट कौन सा है. तो द बेसिक यूनिट ऑफ टाइम इज सेकंड. ऑफ कोर्स वी स्टडीड इन दिस चैप्टर कि सेकंड टाइम को हम कैसे नापते हैं, सेकंड्स में, एंड इट्स बेसिक यूनिट इज सेकंड्स. सो व्हाट इज दिस? द फर्स्ट वन इज करेक्ट. हाउ अबाउट द सेकंड वन? द डिस्टेंस, सॉरी, every object moves with a constant speed. So this is incorrect. Why? क्योंकि यहाँ पे ये बोल रहे हैं कि हर ऑब्जेक्ट कांस्टेंट स्पीड से चलता है, बट यू नो दैट अगर आप किसी कार में बैठते हैं, रिक्शा में बैठते हैं या साइकिल में बैठते हैं, नॉट ऑल ऑफ योर व्हीकल्स मूव एट अ कांस्टेंट स्पीड. इनफैक्ट बहुत कम ऐसे ऑब्जेक्ट्स हैं जो कांस्टेंट स्पीड से चलते हैं. तो ऑब्जेक्ट्स वो शुरू होते हैं धीरे 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 और फिर वो स्पीड पकड़ते हैं, जो भी आपके नॉर्मल एवरीडे ऑब्जेक्ट्स होते हैं, ठीक है. सो नॉट ऑल ऑब्जेक्ट्स मूव एट अ कांस्टेंट स्पीड. So the second one is incorrect. What about the third one? Distances between two cities is measured in kilometers. This is true. Uh, तो अगर आपको कभी बताना हो कि आपको एक शहर से दूसरे शहर जाना है तो वो कितनी दूर है, तो हम अक्सर उसको किलोमीटर्स में बता दें कि हाँ, मुझे दिल्ली से जयपुर जाना है, so that's around 150 kilometers, ठीक है, या 200 kilometers. The fourth is the time period of a given pendulum is constant. तो वैसे तो टाइम पीरियड ऑफ अ गिवन पेंडुलम कांस्टेंट होता है, बट हाउ कैन इट चेंज इफ यू चेंज द लेंथ ऑफ द पेंडुलम? सो द the pendulum's time period is dependent on its length. So it's again incorrect because not all, not in all cases will the time period of a given pendulum be same. And fifth is the speed of a train is expressed in meters per hour. So again, this is incorrect. Why? Because um, a train or a car, its speed is usually measured in kilometers per hour, which is an easier way to measure speed. Okay, so your answers are correct, incorrect, correct, incorrect, and then incorrect. So let's move on to the next question. Question number 3. So a simple pendulum takes 32 seconds to complete 20 oscillations. So हमें given क्या है कि उसको टाइम कितना लग रहा है, 32 seconds. To do what? To complete 20 oscillations. Okay, so what do we have to measure? We have to measure the time period. Okay, तो टाइम पीरियड का फॉर्मूला क्या होता है? टाइम पीरियड इज इक्वल्स टू टाइम टेकन डिवाइडेड बाय नंबर ऑफ ऑक्सीलेशंस कंप्लीटेड इन दैट टाइम. तो हमें टाइम टेकन पता है और हमें ये देखना है कि एक ऑक्सीलेशन में कितना टाइम लगा. ओके, सो टाइम टेकन फॉर 20 oscillations is 32 seconds and how many oscillations were done at 32 seconds? 20 oscillations. तो एक ऑक्सीलेशन कितने टाइम में होगा? 32 divided by 20, which is 1.6 seconds. Since this is time period, the unit of time period is seconds. Okay, so the answer is 1.6 seconds. Let's move to the next question. Question number 4. The distance between two stations is 240 kilometers. A train takes 4 hours to cover this distance. Calculate the speed of the train. तो हमें given क्या है यहाँ पे? हमें distance covered given है. D is equals to 240 kilometers. और फिर हमें ये distance cover करने में कितना time लिया उसने? That's given as 4 hours. So what we can do is we can calculate the speed. तो speed का formula हमने क्या पढ़ा था? Speed is equals to distance upon time. तो यहाँ पे distance कितना दिया है? 240 and time कितना दिया है? 4. So the answer is 60 kilometers per hour. Okay, easy. All right. So let's quickly move to the fifth question. Fifth question में हमें क्या पूछा है? So the fifth question reads, the odometer of a car reads 57321 kilometers when the clock shows the time 8:30 am. तो हमें यहाँ पे पहले तो क्या दिया है कि at time 8:30 am हमें odometer रीडिंग दी हुई है 57321 kilometers. Okay, फिर कुछ टाइम बीता है. The distance moved by the car. What is the distance moved by the car? If at 8:50, now we are looking at the time 8:50, the odometer reading has changed to 57336. So now at 8:50 the odometer reading is 57336. तो हमें ये बताना है कि इतने टाइम में what has been the distance that has been covered. So this is simple maths. आप final reading को distance covered कैसे आ जाएगा? Final odometer reading minus initial odometer reading. Okay, तो फाइनल रीडिंग कितनी थी? 57336 minus 57321, which is 15 kilometers. Okay, next, what are they saying? We have to calculate the speed of the car in kilometers per minute during this time. तो हमें पहले तो क्या करना है? We have to calculate the speed in kilometers per minute. तो हमें स्पीड का फॉर्मूला पता है, वो क्या होता है? इट्स डिस्टेंस अपॉन टाइम. तो डिस्टेंस यहाँ पे कितना कवर हुआ? 15 किलोमीटर्स, राइट. और इस 15 किलोमीटर्स को हमने कवर करने में कितना टाइम लगाया? यहां से आ जाएगा वो, वी टुक 20 मिनट्स. सो डिस्टेंस इज हाउ मच? 15 and the time taken to cover this distance is 20. तो आंसर कितना आ जाएगा? 15 डिवाइडेड बाय 20 विच इज 0.75 kilometers. Now be very careful in units, kilometers per minute. Okay, so this is your distance in meters, in kilometers per minute. Now what are they telling you next? Express the speed in kilometers per hour. Okay, so what do we have here? We have our speed is equals to 0.75 kilometers per minute. Okay, now we have to express this in number of in kilometers per hour. So what do? We'll convert minutes into hours. So 1 minute is equals to 1 upon 60 hours. Okay, so speed can be written as 0.75 kilometers divided by, now instead of minute, 1 minute kitna hota hai? 1 upon 60 hours. So we'll write 1 upon 60 hours. Okay, and then 60 will go into the numerator. So what will be the answer? 0.75 multiplied by 60 kilometer per hour. And this is how much? 45 kilometers per hour. Okay, so your answer is 45 kilometers per hour in kilometers per hour. Okay, next question, question number 6. So Salma takes 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of 2 meter per second, calculate the distance between her house and the school. तो हमें यहाँ पे क्या दिया है? हमें speed दी है which is 2 meter per second, and how much time that she takes from her home to reach her school. वो कितना लेती है? 15 minutes. So she takes 15 minutes on a bicycle from home to school, and she drives the bicycle at 2 meters per second. Okay, so what do? We have to find the distance. We have to calculate the distance between her house and school. So first of all, we write the formula for distance. Distance is equals to speed into time. हमें speed दी है and हमें time दी है. So do we just put in these values? Actually no. Why? Because speed is in meters per second and distance is in speed is in meters per second and time is in minutes. तो हमें यहाँ पे पहले units same करनी पड़ेंगी. So what we'll have to do is we'll have to convert either speed in meters per minute or we'll have to convert time in seconds. तो हम easier वाला करते हैं, हम time को seconds में convert करते हैं. So we can write here time is equals to 15 minutes, or it is equals to 15 into 60 seconds. Why? Because एक minute में 60 seconds होते हैं. Okay, so from here we can write distance is equals to speed into time. Speed हमें दिया 2 meters per second और हमें time दिया है 15 into 60 seconds. So your answer would be, so when you multiply this, 2 into 15 is 30 and 30 into 60 is 1800. What is the unit of distance here? Meters. Be very mindful of the units. So your distance unit will be in meters. So D is equals to 1800 meters. And if you want to express it in kilometers, you can just divide it by 1000 and then you'll get your answer in kilometers, which is 1.8 kilometers. Okay, right. Let's move on to next question, question number 7. So in question number 7, what do we have to do? We have to show the shape of the distance time graph for the motion in the following cases. A car moving with a constant speed. So if a car is moving with a constant speed, let's say in 1 second it goes or let's say, yeah, in 1 second it goes 1 meter. In 2 seconds it goes 2 meters. In 3 seconds it goes 3 meters. And this is just purely for example's sake. So what you can do is you can plot a graph here. Do you remember x-axis and y-axis? So this is your x-axis and this is your y-axis. the distance is represented on the y-axis, time is represented on the x-axis. If here we take 1 centimeter as 1 second, so this is your 1, 2, 3, and if we take distance as 1 centimeter is equals to 1 meter, so this is your 1, 2, 3, and in 1 minute, 1 second it goes 1 meter, 2 seconds it goes 2 meters, 3 seconds it goes 3 meters. So when you join these points, what do you get? You get this graph. So this is your constant speed graph. Okay, uh, you can, for constant speed, your graph will always look like this. Okay, the second one is more important, which is a car parked on the side. Okay, so now what do you do? Let's say you're standing here on one side of the road, and then there's a car parked here on the other side of the road, and you are at 10 meters from the car. So you look at your watch. So you say at time t is equals to 0, the car is 10 meters away. Okay, d is equals to 10 meters. Then, since the car is at rest, it's not moving at all. You look at your watch after 1 second. How far is the car? It's still at 10 meters. Then you look at your watch at 2 seconds. How far is the car? It's still at 10 meters. Why? Because the car is at rest. Remember, it's not moving. You look at your watch after 3 seconds. How far is the car from here? From you? It's still at 10 meters. So then you come back to your home and then you say, okay, now let me plot this. Okay, what I will do is I will take 1 centimeter is equals to 1 second. So this is 1, this is 2, this is 3, this is 4. Of course, you're representing time on x-axis and distance on y-axis. And then you say, I'll take 5 meters as my 1 centimeter on y-axis. So this is 5, this is 10, this is 15, and this is 20 meters. Okay. Now this is the origin. Now when you looked at the car at time t is equals to 0, at how much distance was it? It was here at 10 meters. Again, you looked at the car at 1 second. Where was it? It was again 10 meters away from you. You looked at the car at 2 seconds. It was at 10 meters. You looked at the car at 3 seconds. It was 10 meters. So what do you see here? You see that the graph is being plotted such that the car is always at 10 meters. And then you get a line which is parallel to the x-axis. So when you are measuring this, the speed time, when you are making the distance time graph of something that is always at rest, how will you draw it? You can generally draw it like this. So for an object which is at rest, the graph would be this. For an object which is moving with a constant speed, the graph would be this. Okay. This graph can also be uh, this way. So do not get confused. This is just the distance at t is equals to 0. So let's say if you start recording the time, if you start recording the distance and the car is at a distance from you and it starts at 10 meters. So you take that initial distance into consideration. Do not get confused. A straight line, okay, represents constant motion, and a line which is parallel to the x-axis represents a body which is at rest, right? So moving on to the next question, question number 8. Which of the following relations is true? So they're asking you what's actually the formula of speed, and this is pretty straightforward. I think this should be the easiest question here. The answer is 2. Speed is equals to distance upon time, right? We don't even need to look at the other options. All right. Question number 9. The basic unit of speed is, so the basic unit of speed uh, would be what? Speed is equals to distance upon time. The basic unit of distance is meters. The basic unit of time is speed. Sorry, is seconds. So the basic unit of speed is meter per second. So the answer is 4, right? Okay. Again, this was pretty straightforward and simple. Moving on to the next question, question number 10. A car moves with a speed of 40 kilometers per hour for 15 minutes. So what's happening here? There's a car whose speed is 40 kilometers per hour for how much time? For 15 minutes. Okay. Then with a speed of 60 kilometers per hour for 15 minutes. So for the next 60 kilometers per hour, next speed of 60 kilometers per hour, it moves for this speed for another 15 minutes. So what do we have to find? We have to find the distance covered by the car. So distance, how much distance will be covered? The formula for distance is equals to speed into time. So what we can do is we can find out how much distance it covered when it traveled at 40 kilometers per hour at for time t is equals to 15 minutes, and then we can find the distance it traveled for these 15 minutes when it was moving at 60 kilometers per hour, and then we can just add these two distances and we'll get the total distance. Okay, so your total distance will be d1 plus d2, and d1 will come from here and d2 will come from here. So uh, it's pretty straightforward that distance is equals to speed into time. But what's not straightforward here is that speed is in hours, kilometer per hour, and your time is in minutes. Okay, speed again is in kilometer per hour, and then time is in minutes. So you need to either convert this into minutes or you need to convert this into hours. So we'll do the easier thing. We'll convert time into from minutes to hour. So 15 minutes, if I have to convert it into hours, what will I do? I'll divide it by 60, right? So this is equals to 15 upon 60 hours. Okay. And 15 upon 60 is how much? This is 15 for the 60 if you know your tables. Okay. Or 0.25. All right. So what we can do is we can say total distance is equals to d1, which is speed 1 into time 1. Speed 1 is 40 and time 1 in hours is 1 upon 4 plus speed 2 into time 2. So time 2 was also 15 minutes, which is equals to 1 upon 4 hours. So 1 divided by 4. Okay. So 40 divided by 4 is 10 and 60 divided by 4 is 15. Okay. So what do you get the total distance as? 25 kilometers. Okay. So your answer is 25, which is the second option here. Okay. So let's move on to the next question. A car moves. Okay, this one is done. Suppose the two photographs shown in figure 9.1 and 9.2 had been taken at an interval of 10 seconds. So we saw in the starting of the chapter two photographs 9.1. This is 9.1. Okay. And then this is figure 9.2. We also said that this green car in the center was kind of moving the fastest. Okay. Now what do we have to do from this picture? Just keep this picture in mind. Yeah. So what do we say that suppose these two pictures were taken at an interval of 10 seconds. पहली पिक्चर और दूसरी पिक्चर के बीच में 10 seconds का gap है. Now, if a distance of 100 meters is shown as 1 centimeter on these photographs, calculate the speed of the fastest car. तो आप you take a ruler and you keep your book on the table and then you measure how much distance has the car moved from position 1 to position 2. So let's say uh, this is picture 1 and the car was at here, and then this is picture 2 and then the car has reached here. So let's say this distance was 4 centimeters initially and this distance was then 2 centimeters. So the car has moved how many centimeters? 2 centimeters. Okay. So what they're saying here is कि 100 meters is shown as 1 centimeter in these photographs. मतलब 1 centimeter को हम मान लीजिए 100 meters की तरह represent करें. So if your car has moved 2 centimeters, so in real life your car would have moved how much? 200 meters. Okay. And this becomes your distance. कितनी चली होगी वो 200 meters. और कितने टाइम में फर्स्ट फोटोग्राफ और सेकंड फोटोग्राफ में टाइम डिफरेंस कितना था, 10 सेकेंड्स का. सो टाइम हियर इज 10 सेकेंड्स. तो अगर आपको स्पीड ढूंढनी होगी, स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम. डिस्टेंस इज 200 मीटर्स, जो कि यहाँ से आया, एंड टाइम इज 10 सेकेंड्स, जो कि आपको दिया हुआ है. सो योर स्पीड बिकम्स 20 meters per second. Now this is completely on you. You can just go back to your textbooks and measure how much distance did it go. If it went 1.2 centimeters, then 1 centimeter is 100 meters, 1.2 centimeter is 120 meters. Okay, just multiplied by 100. जितने भी सेंटीमीटर गया, just multiplied by 100, and then you'll get the distance. उस distance को 10 seconds से divide करो, and then you'll get your speed. Okay, moving on to the next question. Figure 9.15 shows the distance time graph for the motion of two vehicles A and B. Which one of the following is moving faster? So you are given uh, a figure here wherein जहाँ पे आपको दो ऑब्जेक्ट्स का मोशन दिखाया हुआ है ए एंड बी. ओके, तो आपको बताना है कौन सी ज्यादा तेज चल रही है. सो यू कैन डू दिस वेरी इजीली. I'll just redraw it in a larger manner to explain it to you more properly by placing values on it. Okay, so let's say this is time, this is distance, this is the motion of one object, and this is the motion of other object. Okay, now you have to tell which is moving faster, A or B. So here the one that is higher is actually moving faster. Okay, the one that is lower is actually moving slower. Let's look at it how. So let's do what? Let's number this. Let's see, this is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds, this is 5 seconds, this is 6 seconds. Okay, let's say this is 10 meters, this is 20 meters, this is 30 meters, this is 40 meters, this is 50 meters. Okay, now let's say for object B, in 1 second how much did it go? It went around 5 meters. Okay, from the graph we can see. But in 1 second उतने ही टाइम में ऑब्जेक्ट ए कितना गया? ऑब्जेक्ट ए वेंट अराउंड 15 meters. तो 1 सेकंड में ऑब्जेक्ट बी कितना गया? 5 meters. और ऑब्जेक्ट ए कितना गया? 15 meters. तो कौन ज्यादा तेज गया? ऑब्जेक्ट ए. सेम थिंग यू कैन सी फ्रॉम हियर ऑल्सो. At 2 seconds, object B went, let's say 10 meters, and in 2 seconds, object A went around 28 or 30 meters. Okay, so again, object A is faster. There's another way of looking at it. So I'll just show you another way. So now, first, what we were doing, we were focusing on time. Let's focus on distances. A को 10 meters जाने में कितना टाइम लगा? A को 10 meters जाने में अराउंड 0.5 seconds लगे, 1 से भी कम. लेकिन B को 10 meters जाने में कितना टाइम लगा? उसको 2 seconds लग गए. So who is moving faster? A. Okay. So for now what we are doing, we are seeing कि 10 meters किसने पहले तय किया? पहले हम क्या देख रहे थे? 1 सेकंड में कौन ज्यादा गया? So in both ways we can conclude that A is faster than B. So the graph which is higher is actually faster than the graph, the object whose graph is lower. Okay. Let's move on to the next question. Which of the following time distance graphs shows a truck moving with speed which is not constant? तो अभी तक हम कांस्टेंट स्पीड वाले ग्राफ्स देख रहे थे जो कि स्ट्रेट लाइन में बन रहे थे. वी हैव टू आइडेंटिफाई द ग्राफ विच इज नॉट मूविंग एट अ कांस्टेंट स्पीड. सो व्हाट अबाउट द फर्स्ट ग्राफ? आई टोल्ड यू इनिशियली दैट यूजुअली वी वर ड्राइंग ग्राफ्स ऐसे, बट अगर ऐसे होगा तो डोंट गेट कंफ्यूज्ड. व्हाई? सो आई मीन दिस इज अगेन कांस्टेंट मोशन. आई विल एक्सप्लेन to you why it is constant motion. Okay, this is a motion which is an object which is at rest. हमने 2-3 क्वेश्चन पहले ये देखा था. Okay, then what is the next? Yes, then लेट्स लुक एट द फोर्थ ऑप्शन फर्स्ट, क्योंकि ये ग्राफ हमने पहले देखा हुआ है. अगेन दिस इज अ मोशन एट कांस्टेंट स्पीड. एंड देन द थर्ड ऑप्शन, दिस इज अ मोशन एट वेरिएबल स्पीड, मतलब नॉट कांस्टेंट. अ मोशन दैट इज नॉट कांस्टेंट इज वेरिएबल. So let us look at the first graph and then let us look at the third graph. ये हम fourth graph already देख चुके हैं. How did the first graph come? So again, let's take the example where you were standing on the side of the road. मान लीजिए आप रोड के बगल में खड़े हैं, ठीक है, और आपके हाथ पे एक घड़ी है. एंड देन देयर इज अ कार, ठीक है, जो कि रोड के दूसरी तरफ खड़ी हुई है. ओके, एंड दिस इज एट 10 meters from you. Okay, and the car is moving is in this direction. So you look at your watch and you say, okay, time is 0 right now. और मुझसे कितनी दूर है कार? D is equals to 10 meters. फिर आपने देखा यार टाइम t is equals to t1 पे, टाइम t is equals to 1 second पे the car has moved 5 meters आगे, 5 मीटर और आगे चली गई. तो कितना मूव किया? 15 meters. आपसे कितना डिस्टेंस हो गया टोटल कार का? 15 meters. फिर आपने देखा यार टाइम t is equals to 2 seconds पे कार 5 meters और आगे चली गई. तो अब आपसे कितना डिस्टेंस हो गया? 20 meters. ठीक है. फिर टाइम t इज इक्वल्स टू 3 सेकंड्स पे आपने देखा कार 5 मीटर्स और आगे चली गई. तो आपसे डिस्टेंस कितना हो गया? 25 मीटर्स. तो आपने कहा कि यार लेट मी प्लॉट इट, ग्राफ पे कैसा लगता है ये. ओके, सो व्हाट डू यू डू? You draw your y axis, you draw your x axis. Okay, then you give this time, और टाइम को आप 1 सेंटीमीटर को 1 सेकंड ले लेते हो. ठीक है, एंड देन आप यहाँ पे इसको ले लेते हो 1 सेंटीमीटर को 5 meters. सो दिस 5, दिस 10, दिस 15, दिस 20, this is 25. Okay, so what do you see at time t is equals to 0? आप आपसे कितनी दूर थी कार? 10 meters पे. At time t is equals to 1 second, आपसे कितनी दूर थी कार? 15 meters पे. t is equals to 2 seconds पे 20 meters पे थी. t is equals to 3 seconds पे 25 meter पे थी. तो अब आपका ग्राफ कैसा बन रहा है? ऐसा. Okay, so now the graph is not starting from 0, it's starting from 10. तो अगर कुछ इनिशियल डिस्टेंस है, कुछ शुरुआत में ऑलरेडी डिस्टेंस है, सो इसको हम t0 पे स्किप कर सकते हैं. एंड देन वी कैन ड्रॉ ग्राफ व्हिच इज अगेन अ ग्राफ ऑफ कांस्टेंट स्पीड. ओके, तो यहाँ पे स्पीड कांस्टेंट है, हर एक सेकंड में 5 मीटर्स जा रहे हैं, मतलब 5 मीटर्स पर सेकंड की स्पीड है इसकी. ऑलराइट, लेट्स कम टू समथिंग दैट इज नॉट कांस्टेंट, जो कि थर्ड टाइप का ग्राफ था. तो हम कहते हैं कि लेट्स सी अ कार इज देयर, वो t0 पे 0 मीटर्स पे होती है. ठीक है, फिर एक सेकंड पे वो 5 मीटर्स मूव करती है. फिर उसकी स्पीड बढ़ती है, अगले एक सेकंड में वो 5 मीटर्स की जगह 10 मीटर्स कवर करती है. तो टोटल कितना गया? 15 मीटर्स. देन इन द नेक्स्ट सेकंड व्हाट इट डज इज इट कवर्स, इंस्टेड ऑफ 10 meters इट कवर्स 15 meters. ठीक है, तो वो 30 meters. और फिर नेक्स्ट एक सेकंड में इट कवर्स 20 meters. ठीक है, तो वो 50 meters मूव गई. पहले एक सेकंड में 5 meters गई, फिर 10 meters गई, फिर 15 meters गई, फिर 20 meters गई. ओके, so now let's plot this. How do we plot this? Simple again, you draw your x-axis and y-axis, right? This is your distance and this is your time. तो आप एक सेंटीमीटर को एक सेकंड ले लेते हो. Okay, and then you take let's say you take 1 centimeter as 10 meters for us. So this is 10, this is 20, this is 30, this is 40, this is 50. Okay, तो आप देखते हो यार एक 0 सेकंड्स में 0 मीटर पे थी, तो कार यहाँ से शुरू हुई. देन इन 1 सेकंड इट वेंट 5 meters. तो कार का एक सेकंड बाद पोजीशन क्या थी? ये थी. देन इन 2 सेकंड्स उसकी पोजीशन क्या थी? 15 meters पे थी. ओके, फिर 3 सेकंड्स में उसकी पोजीशन क्या थी? 30 meters पे थी. 4 सेकंड्स में उसकी पोजीशन क्या थी? 50 meters पे थी. Okay, so how's your graph? ऐसे आके it started curving up. Okay, तो वो ग्राफ ऐसे कर्व होता जाएगा. ठीक है, and this is your non-constant graph. Okay, which is not constant. So this is a third type of graph where the speed is not constant and the distance is changing at a non-uniform rate. So what is next here? It's your some activity which I will not be going into, and let's finish the chapter here. If you have any questions regarding the chapter or the question and answers, do feel free to reach out and comment, and I can get back to you. And have a good day. Do not forget to like and subscribe. Thank you.